Okay, so hello. Today we're gonna learn about this same lesson that is in the main page as a shorter kind of video, and we're gonna build this application, or a variant of it today in class. So what this application does is it uses a camera. Now it has my webcam here, and it should be able to learn different objects that are shown to the camera. So for example, now I show it a picture of a giraffe, and I press this learn button. I'm going to teach it also maybe lion. I have also a picture of a lion, and I'm going to teach it I think that's how you write hippo, but I'm not sure. English speaking person can, like a native English person can correct me. So the way it works is more or less like a small child. Its memory in the beginning is totally blank, and now it only knows a giraffe, a lion, and a hippo. And it thinks that I'm a lion because, well, I'm kind of flattered actually. I mean, the other two options would not be that fantastic. But
I can try for hippo.
Sorry?
I can try for hippo.
Do you want to come here?
Okay.
Okay, well, I'm pretty sure I can confuse it if I add a little bit more darkness there, maybe, yeah, we will see later how it works. So, of course, now it can recognize these pictures because they are exactly what I have shown it, but the way it works is actually even able to recognize some new, not before seen type of animal. I'm going to try now to draw, I mean, not type of animal, but picture of the animal. And now I'm trying to check my talents and draw something. So, I can't really see if it, yeah. Okay. So, wow, this giraffe is actually very, very close to the picture of the giraffe I showed it before. It's more or less coincidence, but we will learn how it works soon enough. So this is what we are going to build today. Hopefully, I have more code material this time than last time. And to build this, we will start with the same thing from yesterday. So if you remember our amazing physics simulation, it's here. Yeah. So we will open the code for this physics simulation. I copied it already in image recognition, even though it's object recognition or whatever. It's an application of machine learning. So I'm going to call it image recognition, and also I'm going to change the title that we see on the page to image recognition. And we are probably going to work with more canvases, but let's leave just one for now. And I don't think we're gonna need the mouse down. I'm not clicking on anything there really. So I will just comment this out in case I'm forgetting something and I do need it later. But now I'm going to keep the functions that I actually need for this application. So get nearest segment, I don't need it. I don't need the segments, I don't need the particles. Simulate physics, there's no physics today, so vector stuff is maybe on hold. then distance between two vectors, it's the same as distance between 2 points, and we may need it in the future. I'm going to keep all the vector things here because maybe I can reuse some of them. I could work just with points, but if I use a little bit vectors here and there, then it's more or less teaching a bit more, like getting ourselves more familiar with that environment. Clearing the canvas, initializing, drawing lines and polygons, these may all become useful. So I'm not going to delete anything from here. I will save the file, go back on the main page, refresh the page, and everything seems a blank, which is supposed to be like that. So first thing I'm going to show today is how to initialize the camera. So I want to start my webcam. That's what we are going to work with. It's going to be our input. And we are going to have here a function initialize. Okay, this font size is too small. Initialize camera, and I'm going to give it this canvas as a variable. Maybe I should rename these with a more meaningful name, because C is quite ambiguous sometimes. Context starts also with C, so people can make mistakes. And I'm also going to get rid of these local variables there. And replace it with this global one instead, which, by the way, a bit more efficient. JavaScript also supports this const variable. That means that this is not a variable. Variables change. This one will stay the same forever. It's going to be constant. Okay, now let's see how this initialize camera function would look like. So it gets a canvas as a parameter. And the first thing we're going to do is something very language related. So I'm going to define a variable that comes from navigator media devices, get user media, and here I'm going to set a parameter inside for video equal to true. Now, how did I know how to do all of this stuff? Googling, researching, going on the internet, searching keywords like how to start camera in HTML. And then you end up to this get user media function. And in this function, I started reading more, and I figured out some of the properties, like if I wanted to start the video, I have to put it to true. Many more useful things are here if you're going to be interested. For example, this facing mode parameter. If you open it on a phone, maybe you want the front camera or the back camera, or maybe you want to toggle between them. So these kind of things, more stuff is available here, and you can look into it, but I'm not going to go to too much detail. Then this promise variable, so this is what happens now is going to be the browser asking me to give it permission to use the camera. So if I'm going to give it permission to use the camera, then I will have a function which has a signal, the camera signal, as a parameter. Now, if for some reason a problem occurs, like I press deny the camera, or maybe the camera is broken, or I don't have a camera on the device, then I can tell it to catch this error. And with this error, I can, for example, make an alert or just displays somehow that, hey, we have a camera error. So alert camera error is something that we can do. But assuming that we say yes and the signal is coming to us, we want to create a video element. So this video element is more or less transforming the signal, the bytes there, into something that you can see. Okay, and I'm going to give it a source. The signal. Now, we talked a little bit before that maybe some of you don't have webcams and you want to do the later projects. More or less this kind of stuff is going to happen when we give already recorded video instead of the camera signal, but I believe something here will be like a URL. We will have to check also that, because it's convenient to work with the same input all the time and not draw giraffes every time we want to test. But maybe we try this next time. Meanwhile, you're free to play around and figure out how that is done. The video needs to be started. And as it is, it's not going to be displayed anywhere. I could display it using a video element, so this kind of element from here, but now it's not included in the document, in the HTML itself. I want to draw it actually on the canvas. I don't want to display the video element, because with the canvas I can interact. I can draw things on top of it, I can get pixel values. From the video object itself I can't do that. It's just showing it there nicely, and I can pause it or operations like that. So what I'm going to do is set an interval, and I'm going to give it a function. I'm going to call this function process video frame, and the interval that it's going to go, let's make it a global variable, and it needs to be passed the video parameter, and the canvas is going to draw things on. So the canvas comes from here and the video is from here. So the interval, let's make it constant, equal to 42 milliseconds. So every 42 milliseconds something will appear. And the reason I have 42 there is, I hope it's a good reason. So 42 times 24, it's almost 1,000. So most of videos out there have 24 frames per second. And if I want this to look like most videos, I'm going to have to refresh the image every 42 milliseconds. So more or less. In this way, the eye will perceive movement and video, not just sequence of images. Okay, but we need this function. And this interval value actually is a parameter for set interval, but these two are the parameters that end up being in the function. This may be a little bit confusing, so I defined here a function which has these two parameters. This one is skipped. This one goes to the interval, telling it how often to update. So you can add as many parameters you want after this interval, and the function can capture them if needed. Okay. Now, in the function, I'm going to want this context So I'm going to access the context of the canvas, and I'm going to use the draw image function that we used in the very first, second lecture, to draw the JPEG image of the house. But now I'm going to draw the video, which surprisingly works. So this is actually a video frame, I would say. So whatever the video object shows at the moment can be displayed as an image on top of the canvas. And I'm going to display it from 0, 0, the top left corner, to canvas size, so the bottom right corner. And hopefully this all works. I'm going to try it now. Going back to our page, and I press refresh. It works. Somehow. I look thin, and that's not a bad thing. So what happens is the camera is squishing the image. The canvas is squishing the image. Usually cameras record at wide aspect ratio, even horizontally or vertically. And now it records on a wide aspect ratio like this, but I ask it to fit it to the canvas, and it's going to squish it like that. So that's why I look taller. You can clearly see it maybe if I put this marker here, and then this pen is more or less the same size, but if I put it like this, you kind of see a very long rectangle. So I'm not that skinny. Okay, so the way you can do this is take the whole image and crop it. You would need, in this case, to remove some parts from each side until it becomes a square. Now, of course, I could make the canvas the same size as the camera aspect ratio, but I want to keep throughout this course this 300 pixels, or at least a square canvas, just so that we don't mess up things later on. And also, it tends to look good in some applications. If you remember the main application I showed before, it had 4 different squares. If one of them would be a rectangle, sometimes horizontally, sometimes vertical one, it would not look good. So it's also some kind of, rectangle and then square, 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 or maybe everything should be the same size, but strange things can happen. So let's see how the cropping would happen here. Before I'm going to draw it to the canvas, I'm going to calculate how to crop it. So what I do is I define a video width variable, and I take it from video width. So this is available in our video as metadata, and the same is going to be with the height. And what I really want to do is find out which is the minimum of these, because if it's a horizontal video, the minimum is going to be the vertical one, and my square is going to be the size of the minimum. And vertical video, horizontal becomes the minimum, and again I'm going to keep the square the size of the horizontal one. So always it's going to be the minimum of these two that is going to be where I crop it. Right? And how much will I crop? Well, I call it here SX. So from X I will crop VW minus minimum divided by 2 on each side. I think so. Yes, on each side. And on the y-axis I'm going to say VH minus the minimum divided by 2. Now note, the minimum has to be one of these two. It has to be, it's the minimum of them. So if the minimum is VW, then this becomes 0. I'm not cropping anything from the X. And if the VH is the minimum, this becomes 0, and I'm not cropping anything from the Y. So I'm always keeping the maximum of the smaller size. And this function here needs to get more parameters telling which part of the video to display. So it's going to start at SX, SY, and it's going to take from the video a size of minimum horizontally and minimum vertically. And these parameters now go only later, but they are still part of the same wall. I save the file, refresh the page, and now I'm fat. Okay, so maybe now it shows the hippo there. Okay, so not much. I figure out how much more is it wider or taller than the other measure divided by 2, so that I take half of that extra from each side and specify it here in the drawing. Okay, so that's everything. We should still test a little bit, but unfortunately I think I can't really test anymore because I already gave permission here. I'm going to open an incognito window and hope this works. Yeah, so now it asks me, do I want to allow the camera? And I can say block, and then I get the alert camera error that I wrote in the beginning. And nothing displays. This is good. This is a good thing. Because if it would display after the deny, then we have a problem. Yeah. But otherwise, for example, and this is for you to know, if you put here HTTP instead of HTTPS, okay, so if I use the secure line or not, if it's HTTP, I'm getting an error, but I'm not getting camera error. Okay, because it's actually not camera error; it's something else, I think. But okay, you can investigate how to deal with that. It won't work. So it only accepts the camera from HTTPS. Okay.
So if we develop into local, we still have to do HTTPS?
No, on local HTTPS doesn't exist.
Yeah.
On local, I think it should work without, let's see. I'm going to view the page source, I'm going to copy it, I'm going to go on my desktop, make a new file, a text file, test.html, okay. Paste the code here. Save it. The extension isn't actually HTML here. I hope it works. No, it doesn't. I open it with Notepad and save as on the desktop. Like that. And now this is the code that I will try to open locally, right? It just works. So it will work locally, but if you will load videos locally, you will have some problems. Okay? Loading videos locally will not work easily, you will have to do some tricks, but I will probably put the videos that may be used for testing on the server, so then you just give the URL and it should work. Locally, the problem is that the videos are on the local disk. So your browser should read from the local disk, and this is a major security problem. Because if any website could read from your local disk, well, it's a problem. Some people don't like their private data readable on a website. Okay, let's continue. So, how does this method really work? It starts like this. You go ice fishing, new guys will go maybe soon. And then you start thinking, will you recognize the fish that you catch or not? And in my experience, it's either ahven or lohi, salmon or perch. Salmon, perch, okay? And I was thinking, could I make a computer program that recognizes these things? And I thought about it in the simplest possible way because I was planning to teach it in high school. And I thought that, okay, this new perch looks pretty similar to the old one, even if I make them like that. So I lose color information, I use texture information, I lose very much information, but looking at them, you still recognize what they are. And I started to think why, what makes them recognizable. And then I remembered this thing, which used to be in the breaks from the main Pokemon series, but even the later series had it. The idea was that during the commercial breaks, kids have something to think about. They are shown something like that, and then they, I don't know, ask their parents for help or whatever to figure out what the Pokemon is. And then it's revealed after the break. But usually it's enough information to recognize them. If my memory is right, this is probably Psyduck, this is Onyx, this is Bulbasaur, and this is Charmander. I recognize them. But now the point of analyzing images. So most likely many of you know these, but I have these slides, so I'm going to show them anyway. That's a building with the lights off, except for some in the middle. Yeah. You can probably recognize what happens when some people have dimmer lights. And then adding color, you are sure who the character is, maybe, because you still have the perception from one angle, okay? So if I'm going to show you a picture of something, you're not necessarily going to understand what is in the picture. And now I ask you to think about those optical illusions that some people paint, like on the floor and the walls and whatever, and from some specific angle it looks like some 3D object is there, or something really cool. You may have seen these things, they were quite popular at some point. If I just show you a picture from the right angle, you're not going to know that that is painted over walls, but you have to be there and kind of move around a little. So a picture does not keep all the information from reality. Color adds some information because here they look quite similar, the two characters. And we are not going to use it today, so definitely we lose some of this information. So be aware that we could make much better system if we use it instead. Or if you use two cameras or whatever. This is happening all the time. But the reason why I want to not use the color and just use the shape is because when you have gray images, they are easily represented as a matrix, a 2D array of numbers. The numbers are between 0 and 255. 0 is black, 255 is white. The main reason why I did this is not because I think you can't handle matrix with some extra dimension there for the red, green and blue, but because I meant it for a high school lesson. And in school, some curricula have matrices in the 10th grade. So yeah, I'm gonna work still with this. Then I mentioned this a little bit. Wow, they are learning also some Romanian there. Oops. You would have never guessed. Yeah, so let's see how we can get the matrix now from the image on the canvas. This is something we haven't really looked at. And the truth is we don't necessarily need to use a matrix. We could also use the raw data, but it's much more manageable as a matrix. It's more understandable. You understand where the pixels are. Like if you see a picture with a lot of red on the top left, it will have, okay, with a lot of white on the top left, it will have values of 255 in the top left of the matrix. So it's intuitive. Because the opposite situation would be to work with the raw data, which is a very, very, very long array of numbers, a one-dimensional array grouped into 4. And every 4 means red, green, blue, and this means, it actually means opacity. So 255 means that it's totally visible, 0 means it's invisible, and between it's transparency. So are you going to see through that pixel or not? It's very handy when you make optical effects, and I'm not sure if we're going to use it, but in this course, important for you to know. Okay. So how do we get this array and make it into a matrix? I'm first going to write the function, and then I'm going to explain it. So after I process this video frame, I want to get gray matrix from the canvas. And I need to write the function. First, we will access the context again, and I will define already the matrix as an empty array. So this is what we are going to populate, and eventually this is what we are going to return in this function, right? Okay, so how to get the image data? Well, we ask the context to get image data from 0, 0 to canvas size, canvas size. And now this image data is actually going to contain the data. I'm going to call it 1D array in its data attribute. So not itself, but it has a data attribute, and that is the 1D array I showed you in this representation. From this 1D array, we want to generate the matrix, the 2D array. So I'm going to loop and I will write the code first and then I will explain it. I think it's much easier that way. Even though it's important to say here that I want to define the ith line of the matrix also, otherwise I will get errors later on. So this is a matrix. It's here defined as a one-dimensional array of lines. So each line is going to be also an array, and it needs to be defined like that in JavaScript. Now our J variable is going to loop in the same way, but this stands for the columns. Right? And every time I'm going to calculate the gray value, let's call it gray value, and say that we calculated, then we will put it in the matrix at the locations I and j. So our matrix will have 300 rows and 300 columns. It's going to have the gray value. But how do we put it there, and how do we obtain it from this one long array of values where every 4 of them are grouped into red, green, blue, and transparency? So I will write this part, hopefully fast. The red component, 1D array of I multiplied by the canvas size multiplied by 4 plus j multiplied by 4 plus 0. Don't panic, it will be explained soon. This is the red component that will create the gray value there. Then green, blue, and alpha, which we actually won't use, but 1, 2, 3. Okay, so I will take a smaller image data array, this 1D array here, and let's draw it in this way. It goes on, but these are 4 elements here, so red, green, blue, alpha, red, green, blue, alpha. So each of them have that. So this is the 1D array, and I want to have the matrix. And our matrix is going to, I'm going to take a very small example here of 4 by 4. It's going to look like that. And in our for loop, wow, amazing. Have it. Not going to come back. Thank you. Anybody knows if it's possible to get it back somehow? I think I just give up. So I do it again and a little bit smaller. And in our for loop, we start with 0, 0. So I is equal to j is equal to 0 here. And if you look at what values we're going to get there, so 0, 0 corresponds to this square right here. It's going to look in the 1D array at 0. So this is 0 plus 0 plus 0. So it's going to look at the first component here, which is red. And then it just adds 1, 2, and 3 to each other. So these different components. And it gets the green, blue, and alpha values. So this is what happens when I is equal to j is equal to 0. When j becomes 1, so j is the one that iterates until 3, so canvas size is 4 in this one example. When j is 1, then this part here becomes 4. So it's going to look in the 1D array at position 4, 5, 6, and 7. So these are going to be 4, 5, 6, and 7. And so on. That's how we are going to get the value here. And at some point, we're going to get I is equal to 1, j is equal to 0. And then this value here is going to become 16. So it's the canvas size, which is, it's actually 4, but the for loop never reaches 4 there. But this value here does reach 16, so then it will jump 4, 4, 4, 4, and put the value over here from this block. and j is going to be 0, and then j increments and so on. So this should be hopefully clear, but it's no trick. It's just converting one data format into another data format. And I didn't do here the most important part. We will average them. So each of those values, the red, green, and blue, are small lights. Okay? If they are all on, then you have the maximum brightness, white. I mean, if they're all on with their maximum value, 255. If one of them is dimming, the gray value is going to dim from white to something else. So if you average these R plus green plus blue divided by 3, you're going to get some kind of gray value. It's not the only way to get gray. There are many color research guys out there that are doing it in different ways. But this is one of them, and easy. Okay, so now it returns our matrix, and our matrix will have the just light intensity. If I want to display this matrix, I'm going to have to write another function, and I'm going to do it faster. Draw pixel matrix. I'm going to give it the matrix and a canvas as parameters, and some of these things will be probably similar. I'm not going to discuss too much about this function because it's very similar. It's just in reverse, more or less. I'm going to get from the canvas the image data in the same way that I did before, and I'm going to modify this image data with the values from this matrix. So this matrix can be anything. If you want to draw a chessboard or whatever, you can do it by putting values in the matrix and then putting it on the canvas. And if you put just values of 0 and 255 and alternate them somehow, then it's going to show a chessboard there. Okay, so I'm going to copy this for speed. So I'm going to need 2 for loops here, and from into our image data object, I'm going to put at the location of I multiplied by canvas size multiplied by 4 plus j multiplied by 4 plus 0 the value from matrix I and j. Note that I'm going to copy this for the green and blue components, and I'm going to put just the same value there because now they are not any different. The gray value means equal values of red, green, and blue. If you know your HTML color codes, like if you see something like this, then this means black. Okay? Then this is going to be some kind of gray. This is going to be some kind of gray very close to white. So everything that has the same values there has the same red, green, and blue components. And the last thing I'm going to put is the transparency. So this transparency, I'm just going to set it to 255. So opacity is maximum. Okay. And one more line of code is going to be to this context. I'm going to say not get image data, but put image data. The value that we modified, so what originally was there, I'm going to add these values, and I start at 0, 0. Okay, so now we get a gray matrix, and we can draw the pixel matrix maybe on a second canvas. canvas B, the matrix. And this process video frame will need 2 canvases now. So see how I add here more parameters by just concatenating there. Initialize camera. Sure, it will start to have many parameters, and camera really displays just one of them. So this may work better as a global variable after all. But let's just work for it now. And here we have canvas A and canvas B, and A and canvas B. And I still need to define down here its pair. Okay, and hopefully these work.
Excuse me.
Yes.
What for you use the second camera?
I'm sorry?
What for was the second camera?
There is no separate camera.
Do you have HTML?
Oh my god. Thank you. Who told me that? Thanks. This is one way that I lose half an hour. Then I start debugging all possible variables, and after a while, oh, it was the other file I opened. So it was that local file that I saved before on the computer to see if the webcam still works. I will explain, Jarmo, your question, but first let's look at why I get many errors. Oh, yes, so this should be 4. Thank you. And most likely I copied it down as well. Yes. Okay, I'm not using 2 cameras. I'm doing something that maybe I shouldn't do. I'm telling the initialize camera function to work with 2 canvases. So I'm giving it 2 canvases because later it's going to process the video frame and display on both canvases something. On one of them it's the original image, and on the other one it's when we plot the matrix on it after it lost the color information. So this right one is now just gray image. If you want to do any kind of processing to this matrix, is possible. So
I have a suggestion
yes.
about this gray image. If you comment out this averaging of the 3, you could try it with the simplest gray formula. That is 0.3 times the red plus 0.6 times the green plus 0.1 times the blue will give you a probably better contrast and better looking gray image.
Can you repeat? 0.3?
Yes, 0.3 times red plus 0.6 times green and plus 0.1 times blue. So it's the least of the 3 components. If you now try the gray image, it should make a better contrast for your image, probably.
Let's see.
Yeah.
So let's keep in mind how this one looks like.
Yes, yes.
Refresh the page.
Semicolon.
I think it's a little bit different.
It's because of your colors. Then it is about it's almost the same, but Yeah.
almost the same. So here what this code means on the top is more or less 0.33 red, 0.33 green, 0.33 blue. But Henry thinks that these values are better suitable for gray image.
No, they are, it's the common
Yes,
color,
yes.
color
I agree. I agree. In color science, that there are these.
they correspond to retina response.
Yes. So people understand these colors differently, not just not necessarily in equal way. So Henry means that this may be a better gray image, and it can be, just that our systems here are not very good at displaying color, so it's not very noticeable difference if we compare. But you see, it's still a value. It's still a gray value. We can even experiment a little more and see that if we keep here just the red component, okay, so our gray value is actually the red value. Then when I refresh the page, it should show the red channel. Now it's a little bit different, noticeable maybe than before. I'm gonna try to show the green channel. A little bit different maybe. Let's see the blue channel. Okay, there are some differences, but the big problem is just that this kind of image now, there are all colors mixed. So now I'm showing it the blue thing, more or less blue. Your eyes see it as blue, but this is not blue. It's many blues. It's many shades of blue. And if I put now the green channel maybe, and I refresh the page, this looks much darker. So all the channels together form a visually pleasant gray value, and most likely this weighted one is going to be more. So the reason it was darker in the green is because there is no green in here. It's mostly blue. There is some green, but very little. Otherwise it would have been totally black. But cameras have noise and many strange things, so... Is that really the time? Okay, let's have a 10 minutes break. Okay, let's continue because we are out of time already, and this application is not going anywhere. I'm very slow today. But you have that supplementary video that explains everything, so I'm not very worried about this. Okay. Now, let's try to process this matrix a little bit. So, I'm going to teach you how to process this matrix. Let's just write the function process matrix, give it the matrix as a parameter, and return and overwrite the initial matrix that we already have. And in this function, I'm going to do something quite simple maybe, just to prove to you that I can do more or less whatever I want. Okay, let's start with much simpler. Matrix of I and j is equal to 255 minus matrix of I and j. And this object actually gets modified, but I have to return it here anyway. What will happen?
Inverse.
Inverse.
Yes.
Okay, so white becomes black, blacks become white, light gray becomes dark gray, and so on. I'm going to refresh this page, and now I look like some kind of horror movie thing. So I'm manipulating the matrix by doing what you want to do with it. I can say, for example, if J is less than canvas size multiplied by 0.66, and J greater than canvas size multiplied by 33, make the matrix of I and J equal to 0. So now I added the black line in the mid-third of the image. You can do any kind of manipulation you want here. I could, instead of doing that, I could add to the matrix maybe a value of 30. I save it. I don't refresh because I forgot the equals sign. Now I refresh. So now I should see a middle part that is slightly lighter than everything else. So I increase the brightness of the image. All pixels went closer to white. So these manipulations can be there, but and you can practice if you want with such a function and create interesting effects. But what we are going to do is isolate the object in the image. So I'm going to write a function to threshold the matrix using a global variable for the threshold. I'm going to say here the threshold is equal to 100. So I'm going to copy this function from here, and I'm going to say threshold matrix with a given threshold. And this means if the value, so if the value of the matrix is less than the threshold, then the matrix becomes 0. Otherwise, the matrix will contain 255. So I'm either gonna have black, totally black, or totally white parts in the matrix. And you can see now that some very strange things are happening, like here in this corner. Okay? You see this fidgeting going on, and it's going on many places. Even though when you look here, you barely notice any difference. This is because our eyes and our brains are very good at considering this the same color, this part here, even though it's not. It's not the same color, it fluctuates very much. And if you're going to say here threshold is equal to 90, it's defined as a constant variable. So I can't modify if it's a constant variable, but I still want to demonstrate this effect. So if your threshold becomes 90, then those points from there disappear. If your threshold is 110, more points appear, and some of them appear there. So computer is very, very sensitive to this type of information. And it will affect very much how your object is separated from the background. And this is quite a simple task here. I have a white background and a dark colored object, but sometimes strange things happen, like the zebra has holes in it. It's a bug or a feature, but anyway, so we understand the zebra as a solid object. Computer sees it as an empty with holes, and maybe it even goes for the giraffe to some extent. Yeah, because the yellow is more up than 100, my threshold that I set there. But it's okay. Let's roll with it. So, we have now a way to capture images, and we have a way to isolate the object. The next step is going to be calculate some properties for these objects. So how the method really works? Well, you have the image, you get the isolated object, we calculate two properties for these objects. First, the aspect ratio, how stretched the object is. 1 means it's a square. Anything closer to 0 is going to be stretched. So this kind of pencil here is marker here is going to be very close to 0 aspect ratio. It's a very, very long object, maybe 6 times longer than its width. And you see that this aspect ratio is different for different objects. So the idea is that if I would put these on a line, these two from here are the two fish, and they are quite different from each other. But the problem is that this giraffe and the camera have quite similar aspect ratio. So this is the case because I want the aspect ratio to be invariant of rotation. If I would rotate it horizontally, then it would have the same looking box as the camera. But I want it to be smart enough to say that this is a giraffe, not just when it is straight. So when you show it something, if it learned these black objects before, we just calculate the nearest object, we find the nearest one, and we take the name of that object, since it's in memory already. But those problems there, they need to be handled. So we can add another property. This fullness property is very easy to calculate. This bottom object here is very full. The rectangle is very black. The giraffe is quite empty. So with this fullness value, our points spread even more. So those two objects are not going to be problematic anymore. And when a new object comes like this other picture of a giraffe, it's going to be close to this other giraffe. Okay, so get object properties of the matrix. And I'm going to say here properties and function get object properties from the matrix. And this matrix is now black and white, right? Okay, so first one, let's calculate this fullness value. Fullness is equal to black pixels divided by the total pixels in the image. So the total pixels is the matrix length times the matrix length. It's the same as canvas size multiplied by canvas size, but I try to use less the global variable. Maybe sometimes we don't. Maybe at some point we won't need it. But how to get the black pixels? The number of black pixels, right? Count black pixels in the matrix. So our function for count black pixels in the matrix is going to start with 0. It's going to do the magic thing. Now I'm sorry, I sometimes use matrix length and sometimes use canvas size, but I want to speed up a little bit. So if the matrix of I and j is going to be equal to 0, it's a black pixel. I increase the counter and I return it at the end. So now I have a fullness value here. Let's try to console log the property and just return the fullness. I save the file, refresh the page, and now I'm getting values here, like 40, 40 something. I'm gonna try to put this here. I'm gonna get values close to white and close to 0. And this is a problem that you will find in webcams that computers don't really like. When you bring objects close to the camera, even though they're dark, the camera is going to change its settings. Notice how my hand is now, okay, I'm covering the webcam entirely, and it's somehow seeing through my skin. So when I immediately let it go, you notice that I am very bright. So this computer is too smart. It actually causes many problems for me. Immediately when I do this, you will see 1 there in the log, and then you see 0 because everything is so bright for a second. These changes add to the noise effects and whatever, but I trust the fullness value at the moment. So if I'm going to show it, for example, this zebra, I will have a fullness value of 0. I can't read it, but 0.03. Okay, and if I will show it something more robust like this elephant, 0.12. So something works there, but I need to calculate the fullness relative to this property, to this bounding box here. Its size, not the whole picture area. So let's obtain this bounding box now. So function get bounding box from the matrix. I'm going to say an object with the minimum x coordinate. Let's call it, let's give it a value of infinity. A maximum x coordinate of 0. A minimum y coordinate of infinity, and a maximum y coordinate of 0. I hope it becomes clear why I'm doing that. But more or less, going through the matrix, and if matrix of I and j is black, if I is going to be less than x min is going to become I. So I'm keeping the leftmost part of the black part in my image. And I could do the same thing with the others, but there's a faster way to write this. Is x min is going to be equal to math.minimum between whatever x min is and I. So in one line, and it makes sense. So in the beginning with x min is infinity, it will immediately become canvas size or something. That's why I want my minimum values to be extremely large and our maximum values to be as small as possible. So I have the same for y min, and here I'm going to have maximum value for the max variables. And yeah, I forgot to do this. So these are attributes of the bbox, of the bounding box object. So I need to put bbox dot before, and now I can return the bounding box. Okay. Now with this bounding box, you can calculate, for example, delta x is equal to b box x max minus b box x min. And I can do the same with the y. And I can calculate the width equal as the minimum of whatever delta x and delta y are, and the height, even though this just means smallest of the two and biggest of the two. So I want my aspect ratio to be between 0 and 1. I will divide the width to the height, the smaller one to the bigger one. And here, when I'm dividing the fullness to the full matrix size, I don't want that. I want the fullness to be just relative to this width and height of these particular objects. So here matrix length becomes width and the other matrix length becomes height. And now I return aspect ratio and fullness. And our object is still returned and printed to the console. So I'm gonna refresh the page. And I have two values here. The aspect ratio is 1 because you can see black here and black here. But if I'm gonna do this, it still is 1. So there is a problem with our function. If somebody can help me spot it, then that would help. I'm going to, no. I'm going to output this bounding box just to make sure that it is calculated correctly. Okay, so the bounding box 0 to 299, it's always this much. Oh, no. Okay, the x and y max, this shouldn't happen. I think there is a typo somewhere there. In get bounding box, x min, y min, x max, y max. Anybody sees the problem?
I think it's y min is right.
I'm sorry?
I think that's y min is j.
I'm sorry?
Y b box down y min is min b box min and j, not I.
Why do you have I in the parameter?
Oh, yes. I is for the vertical direction and J is for the horizontal direction. I think it needs to be like this. Sorry. Yes, it's so here I want to find the index in the matrix with the leftmost, upmost, rightmost, and bottommost black value. So the indexes are I and J.
Okay.
Right? And I'm working with the index, not the... Okay. So now, okay, now the x max is going smaller and smaller because I'm creeping in from the right side. I think it's correct, but let's see the full properties. So, yeah, like that, and I don't need this logging of the bounding box anymore. So now, if I'm going to show it, for example, the horse, it's going to say aspect ratio of 0.90 something, so this actually looks pretty much like a square, the bounding box of this object. It's a tall horse, but also quite long. So 0.95, and the fullness 0.36, so relatively small. If I'm going to show it the hippo, then aspect ratio is smaller, it's 0.6 because this is a long animal. And the fullness is 0.68, so it's more than the horse because it's more or less all colored in. So the properties are correct, but now how do we store them in the computer's memory? I'm going to need to have a button here. When I click it, I want to learn something, so I will need a function. The button is going to say learn on it, and I'm going to also need input field. Let's give it an ID input, which is empty. So these are going to be somewhere at the bottom, I guess. And I'm going to need the learn function. So the learn function is going to be called when I press that button. And I want to know the current object properties here. So easiest way is to keep this as a global variable. For example, current properties. Current properties, I will define it as a global variable. Variable, these change. And in the learn, I want to associate these current properties with the name that I type in the input field. So I'm going to say observation is equal to name, document get element by ID, input dot value, maybe. And current properties, I'm gonna go back to vectors this time, and I'm gonna say the current properties of aspect ratio and the current properties of fullness are going to form a feature vector. So these are our features, and this is what feature vector means. Vectors are everywhere, you're not going to escape from them, and the same operations apply almost all the time. Okay, now let's have the memory. So memory, an array of objects. In the beginning the computer knows nothing. When I calculate a new observation, I'm going to say add. Push is the method for adding in an array in JavaScript. The observation. And that's it, more or less. We could do a check here. We get the value, and if it's empty, if somebody doesn't put a name there, we could say return. We don't memorize anything, but we alert the user, hey, put some name there. Okay, now let's refresh the page. Some errors here and there. Oh, notation is wrong. So when I'm creating this type of object, I need to use columns, and I also have to say here feature, for example, features or feature vector. Could be one way of doing it. I refresh. Okay. Now, console, memory is empty. And if I write here me and press learn, apparently nothing happens, but memory contains me and my two features. Okay? And if I'm going to say blue thing and I press learn, then memory is going to contain two things. One is the blue thing and its features. Okay, the first one is the same, but the second one is slightly different. So it memorizes things. Now we just need it to classify things. So it's going to be the last step here. Function, classify. And when we classify, we want to have a place where it can display things. So I'm going to put here, let's just put a div. I'm calling it output. And our classify function is going to put in the output the name of the object. But what is the name of the object? We take the nearest object in the space. Get nearest neighbor. For our current properties, I could keep them as global, but let's just do that. And memory. So look for the current properties in the memory. Okay, this is not nice. I want to create a feature vector. So now the current properties are as a feature vector, and I'm going to tell it, find me the nearest thing in memory to the vector of the current thing it sees. So, get nearest neighbor, item set or collection, and I just have to calculate the minimum somehow. So for each point in the set, for each vector in the set, I'm going to calculate the distance from our current item to it. And if this distance is going to be smaller than our previously found minimum, then our new minimum is going to be the distance, but I want also the object. So our neighbor is going to be null, but immediately when we find a better one, our neighbor is going to become the ith element in the set, and we are going to return the neighbor. Now, if the neighbor is equal to null, sanity check, I'm just going to say that I don't know. So our computer is going to output question marks. Okay, it has not learned anything yet if there is no nearest neighbor. There has to be a nearest neighbor always if it learned something. Otherwise, we are going to take the name of the neighbor. So if you remember here, our memory contains things with name and features. Okay, a little problem here. So I'm going to rename this to memory, and I'm going to say here features, because this is not a vector, but features is a vector. A bit confusing, but yeah, I had to speed up. Let's see now what happens. Nothing, which is concerning. So I want my output, but where is my output? There. Oh, I'm sorry, I probably make a few mistakes here. But if you know what I'm doing wrong, then let me know. So our output div should get inner HTML of something, but let's, sorry? I'm gonna output the neighbor just to debug. Oh, stupid. This function is not called anywhere. Maybe that's what you wanted to say, but I'm not listening now, I'm sorry. So process video frame, draw pixel matrix, whatever. Anytime after I have the object properties, I can run classify. Now I refresh the page. Okay, question marks. And to test, I'm gonna do something faster, and I have no idea it works under these conditions, but more or less, I'm not going to use those animals because it's tedious and it takes time. I'm going to say here up, and I'm going to be here like that. And now I'm going to write here down. You can see it classifies me as up. I'm going to put that down. And I'm gonna go up and down and up and down, and tell me when you're convinced that this somehow works.
Not yet.
Not yet. Okay, so now actually the fullness property is the only thing that works. The aspect ratio is almost full because this background is complicated. But the application is able to learn even with the fullness property, because many things change, like all this black here is hidden by my light colored shirt. So there are these differences there. I would have liked to do more things, but today's day is not very good, and I do squats when I'm ill. So anyway, thanks, and see you on Thursday.